Callie Hill, yes. Yes, you need four materials. I don't care how many hooks it has. It needs one, but the number of hooks doesn't necessarily matter. And we'll talk about that more at the end. Okay, let's go ahead and get started with our class. So we've been talking about viruses. Um, okay, hey guys. So say questions for the challenge after we get through our little lesson. Okay, so let's do this first. We've been talking about viruses, and we started out with just kind of an intro overview, looking at viruses in general, talking about how they're made, what they do, how they act. Then we looked at bacteriophage, and we saw it was pretty crazy because we know that bacteria can make us sick and viruses can make us sick, but these viruses were a bacteriophage is a virus that attacks a bacteria, so it can essentially kill a bacteria. We had some assignments off of that. We talked about how we could use that information maybe one day to cure us of bacteria diseases. So that could be helpful, useful. We looked, I guess, Monday at viruses that can affect humans and animals. And today we get into a very, very, very important aspect of virology, and that is how viruses evolve. Okay, so when I say evolve, another word for that is natural selection. In the text box, somebody explain to me, summarize, how does natural selection work? How does natural selection work? I'll give you a few minutes. Okay, that's artificial selection. They choose. Um, that's a pretty good explanation of artificial selection, Remy. Dakota. Dakota, that is a very good answer, Dakota. Good job, Dakota. Very proud of you. Um, so if I was going to summarize natural selection, basically there are traits that help organisms to survive. Okay, if I'm a giraffe and I live in a place that has really tall trees, my long neck helps me survive. And so if my offspring get genes from another parent that make them have a short neck, they might all die. Okay, so only the ones with long necks in that scenario would survive. Well, all organisms go through some variation of natural selection. Okay, there are things that make it easiest for us to survive. There are things that make it hard for us to survive, and those traits that make it easier tend to get passed on. Sometimes maybe the organism lives for a while, but not the full extent of their life cycle. And we're going to that in a minute. That's very important. Um, Viruses, however, evolve really fast, much faster than the normal organisms. And there's two ways they evolve. First is called recombination. Okay, recombination. It means exactly how it sounds. Recombining things. So what it does is when that virus gets in the cell, it combines its DNA with other DNA or sometimes RNA. It might attach to the host DNA, but sometimes those viruses link together. And when that happens, you get new traits. Okay, you get new characteristics. That offspring doesn't look just like mom and dad. It looks a little bit different. It acts a little bit different. Has its own unique traits, and now you have a new virus. Another one. So the flu virus, or the flu virus, goes through recombination. So I don't know if you know this or not, but once you get a virus, this is going to be confusing at first. I'll explain later. Once you get a virus, you can never get that virus again. You can never get a virus that looks like that virus again because your body figured out its techniques, and your body makes it where it can't be infected by that again. And so you might be asking yourself, how can I get the flu this year and then the flu again next year? Or maybe you're saying, well, Coach Harper said that a cold was a virus, and I got a cold in fourth grade, and fifth grade, and sixth grade, and seventh grade, and eighth grade. So how can that be? Well, remember a while ago I said they evolved really fast. And so when they combine that DNA, that virus doesn't look the same and it doesn't act the same because it happens really quick and really often. So that means that, yeah, maybe you got the cold virus, maybe you got flu type A last year, and you didn't get a flu shot, but the evolved flu type A, so it's still flu type A, but it looks different, it acts a little bit different. Now you can be infected by that also, okay? So it's something we have to really be careful of and cautious of. The other type of way that it can change or evolve is that it goes through what we call a mutation. Okay, so in your body, in every cell you have these amino acids that basically they proofread your DNA before it goes to the ribosome for the proteins to be put together. Okay, and so the reason it has to proofread it is because a lot of times problems happen. Okay, maybe there was a combination of things that make your DNA off somehow. I don't know. There's different things. And so when it reads your DNA and it sees there's a problem, it throws that out and gets another piece. But viruses don't have that amino acid. So when viruses make their DNA go to your ribosome, there's no proofreading. So mistakes happen a lot. And sometimes those mistakes mean that the virus that is created is malformed. It can't work right. But sometimes it means it just looks different or acts different. Okay? That's one form of how viruses evolve and change over time. Thankfully, we have a method that we have created called to treat viruses. Yes, yes, Carly. It can mess up. So we have lots of different ways to treat viruses, several different ways to treat viruses. One is vaccinations. But one way that we treat viruses is called the HAART method. HAART, HAART. It stands for Highly Active Antiretroviral Therapy. Now, retroviruses are very, very bad. They're very scary. HIV is a common form of the retrovirus, of a retrovirus. And what it does, this HAART method, it's not just a vaccination. It's not just medicine you take. It is a system that attacks the at 3 stages of its life cycle, okay? So we're not just focusing on one spot. We try to hit that virus from every angle because it is very, very, very unlikely that a virus evolves so that all 3 stages of its life cycle are different. And so that HAART method is really, really efficient and good at taking care of viruses. So that way we can even kill and cure viruses that are rapidly evolving. Okay, we're almost through with class. One thing I do want to talk about is, why do viruses evolve so fast? We said a while ago that most organisms, you don't even notice the change in the species over a lifetime. So why do viruses evolve so fast? Anybody have any ideas? If you do, I want some of you guys to drop your ideas in the chat box. Why do you think viruses evolve so quickly? Okay, because people spread them. It's not just people, animals do too. Okay, people spread them quickly. It's not a bad answer, Parker Hood. See what else we got. In contact with a lot of DNA. That's very good, Ethan. That's a good answer. There are 2 main factors. There are others, but there are 2 main factors that make it easy for viruses to evolve so fast. The main thing is their population is so extensive. If you think about, I don't know what the latest numbers are. Somebody might want to look it up and let me know in the text box. I don't know how many people are infected with the coronavirus right now, or at least have been, but I know it's over 1 million. And of those 1 million people, each one has millions of viruses inside of them, maybe trillion, a lot. Okay, so each host has millions and millions and millions of those viruses inside of them. That's a lot of that's a very high population. Well, with every single one, they're creating offspring, and it's not even like animals. Like with an animal, every 2 animals make an offspring, right? So you got a mom and a dad. Viruses, no way, Jose. Each virus is having an offspring. So if I've got 100 cattle, let's say each female cow has an offspring, and I have 100 bulls, 100 cows, I'll have 50 calves. But if you have 100 viruses, they're gonna each time they reproduce, it's gonna be another 100, another 100, another 100, and so they multiply exponentially. And so their population size is huge. The second thing is viruses have a very short life cycle, right? So natural selection works over generations and generations and generations. No change is very fast. No change is usually very noticeable. But in viruses, it's different because, for example, an HIV life cycle is only 52 days. Well, a dog, the average life cycle for a dog is like 12 years, right? A human is like 80 years. So generations and generations and generations take change for it to happen. Now, why is this a big deal? One reason it's a big deal is because these mutations and these evolutions are usually just random, but sometimes the change, here's what has to happen. The random change has to happen where it could affect a human. Let's say this is a virus in a pig, okay, like the swine flu. It has to evolve so that humans can be affected, and then a human has to come in contact with that virus. So, for example, as of, I don't know, February or December, no known tigers had ever gotten the coronavirus. Tigers can't get it. It came from bats, so bats could get it. At that point, humans could get it, but not tigers. There was a zookeeper in the Bronx Zoo, and the virus evolved inside of their body, and it came in contact with a tiger. Just so happened the evolutionary change made it so that it could affect tigers, and now there's a tiger in the Bronx Zoo who has the coronavirus, and some of his friends, they think, have got the coronavirus, some tigers and lions. So that's kind of crazy. That means that it's evolving pretty quick. Nothing to be afraid of, really. Let's see. Hold on one second. Let me check that comment out. That was a big comment. Anyone that uses milk or eats meat are contaminated already because it may be. No, Atlanta. That's not what that means. So I'm glad you asked that. That doesn't mean that every animal gets it. Okay. That doesn't mean. And also in America, meat is tested very, very carefully. The market that this came from in China, their meat is not inspected by anybody or anything. You can bring any piece of meat and lay it on the ground and sell it. You can't do that in America, okay? So you don't have anything to worry about that. That does not mean you're infected. And also, something I want you all to know, the information I'm giving you does not make this virus any more deadly. It's nothing to be afraid of right now, like the information I've given you. But it is important for you guys to know the truth so that you can be armed whenever you hear fake information or false information, right? The virus can't just evolve intentionally to make it worse for you. Okay, it is random. It's a chance is all it is. Okay, and it usually doesn't do anything to affect us, but sometimes it does. Let's see. Let me read. See. All right. Yeah. I'm sorry. I mean, that's bad. Okay. Good question, Kayla Hill. So if you are in prison, fix this camera right here. If you are in prison and you get the coronavirus, they isolate you. You're not around any other people. You are away from everybody.
Wow.
Yeah, Emily. There's I think 18. I think you're about right. Guards and uh, inmates. That's really sad. Okay, that is the end of my class. So now we are going. Remember, so we're going to log in from now on Mondays, Wednesdays, and Fridays. We won't log in on Tuesdays and Thursdays. I have uploaded class notes and 2 more videos that you guys need to watch. Okay, so I'm giving you material today, but I'm not giving you assignment. So I need you guys to be very diligent. I need you to consume that material. I need you to watch the videos and read the notes. Your engineering challenge, the fishing lure thing, is due Friday. Okay, so make sure you get that all finished. If you're having problems uploading a video, there's 2 ways you can do this. You can put your video on YouTube and then put it to Google Classroom. Parker Hood, you turn it in the spot where I assigned it. Okay, just like any other assignment. So you can do your explanation in Google Docs, and then you can upload your pictures in Google Docs, and then you can upload that to Google Classroom. Great question, Parker Hood.
Yes, sir.
If you have videos you want to share, Friday we're going to kind of have like show and tell. So have your lures ready to go when you log in, and we're going to talk about it, and then you're going to get your next challenge. Okay. Are there any other questions? Okay, guys. If you don't have any questions, you can log out. Have a good day. Stay safe. Wash your hands and stay away from people. Okay.
Coach Albert.
Yes.
I've been thinking of a way how they could actually stop the coronavirus.
All right. I'm listening.
They could take stuff like medicine for the flu,
Yeah.
and then take some coronavirus DNA and combine it. See if that works.
Well, the problem is the flu and the coronavirus are two completely different viruses, and so things that stop the flu don't affect the coronavirus. It's a good idea, though.
What thing did you say that was right? That looked like the coronavirus thing?
I don't remember, bud. What are you talking about?
I remember last week you said something about something looked like something looked like the coronavirus, something that looks like the coronavirus. That I like the pictures of it.
Oh yeah, one of the pictures in your notes looks kind of like the coronavirus. It's a different type of virus, though. Yep.
Coach Albert,
Yes.
I think I'm doing great with Corona. I'm not 6 feet apart, but it's okay.
Why do you say that?
I'm in Walmart and everybody's coming to me.
Girl, you better stay away from them. I see you.
I
Miss.
saw your line.
Yeah,
I
she's
saw
in
your
there.
line.
She's in there.
You were stupid. Get out of Walmart.
I tried joining it. I was just busy.
Did she have her scarf on her face?
Yeah.
Yep. You should find her and put her on the class.
Should?
Yeah. But don't. Hey. Last week, maybe a week before last, we were in Walmart together, and there was like this old student that used to go to Palestine, and she come running up to Miss Halbert and tried to hug her, and she like, stop, no,